Metric prefix and dimensional analysis. The International System of Units, abbreviated as SI or SI units, from the French Le Système International des Units, is the modern form of the metric system. The system has been nearly globally adopted. Only Burma, Liberia, and the United States have not adopted SI units as their official system of weights and measures. In the US, metric units are not commonly used outside of science and medicine. The UK has officially adopted a partial metrification policy with no intention of replacing imperial units entirely. Canada has adopted it for most purposes, but imperial units are still legally permitted and are commonly used, mostly by old people. SI units are: we measure time in seconds, current in amps, distance in meters, power in watts, mass is measured in grams, force in newtons, energy is measured in joules, and pressure in pascals. The metric system was first implemented during the French Revolution in the 1790s, with just the meter and kilogram as standards. Since then, scientists and government officials decided that in order to communicate findings and help with trade between nations, an international way for measuring must be adopted. Depending on the area of science that you are studying, certain particular metric prefixes will be commonly used. If working for SaskPower, you will frequently use gigawatts, megawatts, and kilowatts. Highways use kilometers. Farming often uses hectares. Medicine will involve small measurements of cc's, known as cubic centimeters, as well as milligrams in prescriptions and micrograms in toxicology. So these are the metric prefixes that you will need to be familiar with. You should add these to your periodic table for reference if they are not already on there. So pause and add to your data table. Conversions in science are done through dimensional analysis, a method that has your given multiplied by a set of brackets that change the unit, but not the amount. The steps of dimensional analysis are: we start by writing down our given. We then make a large set of brackets with a fraction inside those brackets. You put the unit you want to get rid of on the top or the bottom of that fraction. You put it on the side that will allow it to factor out with the unit that you have in the given. Then you put the unit you want to convert to on the opposite side of that fraction. Then you put numbers into the bracket that will make the numerator equal to the denominator. You continue to make brackets until you have achieved your desired unit. Then you place it into your calculator by first punching in the given, then multiplying by the numerator and dividing by the denominator in each bracket. I want to point out and make it absolutely clear that you put the units in before you place numbers into the brackets. So when you draw your brackets, and this is a mistake that lots of students make, they try to put in the numbers at the same time as their units. So units go in the brackets first. Once you have a unit in the numerator and denominator, then you put numbers in that will make top equal to bottom. Example 1, how many meters in 24 centimeters? So I start by writing down my given, which is 24 centimeters. Now make a large set of brackets with a fraction inside the brackets. So a large set of brackets with a fraction. Put the unit I currently have in the brackets so it will factor out. I have centimeters, it's in the numerator, so I'll put centimeters in the denominator so they can factor out. I'll put the unit I want to convert to on the opposite side of the fraction. I have centimeters on the bottom, so I'll put meters on top because that is what I'm looking for. Now I put numbers in the bracket that will make the numerator equal to the denominator. Well, I see I have centi, and centi equals 10 to the negative 2. So 1 centimeter equals 10 to the negative 2 meters. So in my bracket, I'll put 1 with centimeter and I'll put 10 to the negative 2 with meter. Now top equals bottom. I continue to make brackets until I have achieved my desired unit, which I want meters, and this will leave me with meters, so I am done. Now I have to place it into my calculator. First I punch in my given, which is 24, so 2, 4, and then I multiply by my numerator, which is 10 to the negative 2, so times 10 to the negative 2, and that's not a minus sign, that's a negative sign. If you hit the minus sign, you will get a domain error. So you have to make sure that you're pressing the negative sign instead of the minus sign. And then it says I have to divide by the denominator. So divide by 1. And then I hit my equal sign, and that gives me 0.24 meters. Example 2, how many megawatts in 2.4 gigawatts? This is different than the previous example because I see two metric prefixes. I'm starting with giga, and I want to go to mega. This will require two brackets. The first bracket will get rid of our current metric prefix of giga. Our second bracket will add on the new metric prefix of mega. So I will write in by given 2.4 gigawatts. Make a large set of brackets with the fraction inside the brackets. I put the unit I currently have in the bracket so it will factor out. I have gigawatts. It's in the numerator, so I'll put gigawatts in the denominator so that they can factor out. I then put the unit I want to convert to on the opposite side of the fraction. And remember, I said the first bracket is going to get rid of our current metric prefix. So if we get rid of gigawatts then becomes just watts. Now I put numbers in the bracket that will make the numerator equal to the denominator. So G is 10 to the 9, so 1 giga equals 10 to the 9. So 1 gigawatt equals 10 to the 9 watts. So I'll put 1 with gigawatt, and I will put 10 to the 9 with watts. Now top equals bottom. 10 to the 9 watts equals 1 gigawatt. I continue to make brackets until I have achieved my desired units. Right now, if I did this calculation, it would take me to watts, but I want to go to megawatts. So I will have to continue to make brackets. So I will have to repeat the steps starting at number 2, which is make a large set of brackets with a fraction inside the brackets. Put the unit you currently have in the bracket so it will factor out. Gigawatts and gigawatts have already factored out. I currently have watts, so to get rid of watts, I'll have to put it in the denominator so they can factor out. I put the unit I want to convert to on the opposite side of the fraction. I want to convert to megawatts. I put numbers in the bracket that will make the numerator equal to the denominator. Mega is 10 to the 6, so 1 mega equals 10 to the 6, so 1 megawatt equals 10 to the 6 watts. So 1 megawatt equals 10 to the 6 watts. So I'll put 10 to the 6 with watts and 1 with the mega. Now top equals bottom. 1 megawatt equals 10 to the 6 watts. I continue to make brackets until I achieved my desired units, and right now this would take me to megawatts, which is what I want. So now I can place it into my calculator. I first punch in my given, so 2.4, and then I multiply by the numerator, so multiplied by 10 to the power of 9, and then I divide by my denominator, so divide by 1. Then I have to multiply by the next numerator, so times 1, and then divide by the second bracket's denominator, so divide by 10 to the power of 6. And when I hit the equals button, it says 2,400 megawatts. Again, make sure you are punching this into your calculator as we work through the examples to make sure that you are entering this correctly into your calculator. Example 3, how many meters per second in 27 kilometers per hour? I'm going from kilometers per hour to meters per second. That's going to require more than one bracket. because we are converting kilometers to meters and hours to seconds. We'll write down our given, 27, but we're going to be careful when we write the unit. We're going to put kilometers clearly on the top, hours on the bottom. Nice fraction like that. Make a large set of brackets with a fraction inside. Put the unit we currently have in the brackets so it will factor out. And I could start with either kilometers, or I could start with hours. In this case, I'm going to start with kilometers. If you started with hours, your brackets will follow a different order, but in the end, we'll wind up with the same answer. So I'm going to start with kilometers. I put it on the bottom so they can factor out. I put the unit I want to convert to on the opposite side of the fraction. I want to switch kilometers to meters. I'm getting rid of the metric prefix, kilo. I put numbers in the brackets that will make the numerator equal to the denominator. On our chart, we see kilo equals 10 to the 3. 1K equals 10 to the 3. 1 kilometer equals 10 to the 3 meters. So 1 kilometer equals 10 to the 3 meters. I continue to make brackets until I've achieved my desired units. If I punch this into my calculator now, I would wind up with meters per hour. And that's not what I want. So I put in another set of brackets with a fraction inside. I want to get rid of hours now. I want hours to be converted into seconds. So I'm going to put the unit I currently have in the bracket so it will factor out. Since hours is in the denominator, to factor it out, I will have to put it in the numerator. I put the unit I want to convert to on the opposite side of the fraction. I want to go to seconds. But in between hours and seconds are minutes. So I will have to convert first to minutes, and then I will be able to convert from minutes to seconds. So in this bracket, we're just going to go from hours to minutes. I put numbers in that make top equal to bottom. There's 60 minutes and 1 hour. And again, I continue to make brackets until I'm at my desired units. So I'm going to put in another set of brackets with a fraction. I want to get rid of minutes. So I put the unit I currently have in the bracket so that minutes will factor out. I put the unit I want to convert to on the opposite side. I want seconds, so I'll put seconds on the bottom. I put numbers into the bracket that will make top equal to bottom. And there are 60 seconds in 1 minute. So 1 minute equals 60 seconds. And it looks like I'm good because this will give me now meters on the top, seconds on the bottom. Now to punch this into our calculator. First, we punch in the given, so 27, and then we multiply by the numerator times 10 to the 3, and then divide by the denominator, so divide by 1. Then we multiply the second bracket, so multiply by 1, divide by 60. And then the third bracket, so multiply by 1, divide by 60. And that equals 7.5 meters per second. I want you to note that so far our answers have always been given with the same number of significant figures as the given. In this case, the given was 27 kilometers an hour, and 27 has 2 significant figures. Our answer is 7.5 meters per second, and 7.5 has 2 significant figures. So make sure that you are rounding your numbers so that you always wind up with the same number of significant figures as the given in the question. And that's the end of the lesson. You're good to start the assignment.